In this video, we will be reviewing how to simplify expressions using the laws of exponents. So when you have an exponent, you have your base, which is your big number or variable on the bottom, and then your exponents on the top. So we have several rules for exponents. If you have a zero exponent, then whatever has the zero exponent is going to become equal to 1. If you're multiplying, you add your exponents. If you're dividing, you subtract your exponents. If you have an exponent of an exponent, you multiply those little numbers. And then if you have a negative exponent, it's like you're taking the reciprocal. So it doesn't mean your answer is negative. It just means that you're going to flip it. So if it's in a numerator, it becomes in the denominator. If it's in the denominator, it becomes the numerator. So here we have some examples. In our first example, we have m to the 7th times m to the 8th. This is a multiplication problem. When we multiply, we add exponents. So we're going to add 7 and 8 together, and we get m to the 15th. Our next one's also multiplication, so we're going to add exponents. So we're going to add 12 plus negative 4 plus 6. That becomes 8 plus 6, or c to the 14th. And then in our next one, we're dividing. When you divide, you subtract the exponents. So here, we're going to do the numerator times the denominator. So it's b to the 8 minus 2, which is equal to b to the 6th power. In the next problems, we're going to be dividing, but there's going to be more terms. So we'll just take it one step at a time. So when you do your big numbers, your constants that are in front, your coefficients, you do them like normal. So here, 8 over 4 are not exponents. So you're just going to divide 8 over 4 like you normally would. So 8 divided by 4 is equal to 2. Now I'm going to do the m's. If there's no exponent, you can put an imaginary 1. So we have m to the 3rd over m to the 1. Remember, when you divide, you subtract exponents. So here, this becomes m squared. And then we have n squared over n cubed. So we're doing 2 minus 3, which is n to the negative 1. So I'm going to put all of these together. So our answer is going to equal 2m squared n to the negative 1. Now here there's an additional step because we don't want negative exponents. So when you have a negative exponent, you're going to write your answer as a fraction, and you're going to move whatever has a negative exponent to the denominator. So here, I'm going to rewrite my answer as a fraction. And then the 2m squared goes on top. Since the n had a negative exponent, I'm going to move it to the denominator. And when you do that, the negative exponent becomes a positive 1. And then there, just at the end, your 1 can be imaginary. So my answer is 2m squared over n. The next problem, we're going to do it similar. So we have 2 cubed over 2 squared. 3 minus 2 is 1. Then we have c to the 4th over c to the 4th. 4 minus 4 is 0. Now remember, we learned anything to the 0 power is equal to 1. And then t squared over t squared, we do 2 minus 2, we also get 0. So that is also equal to 1. So we put all of this together. Here, sorry, 2 to the 1st power is just 2. We're really going to be having 2 times 1 times 1, which is equal to 2. Now, there's a shortcut here. Anytime you notice you have the same exponent in the numerator and denominator, it's like they cancel, because anytime you divide the same thing by itself, you get 1. So here's c to the 4th over c to the 4th. Since they're the same, They cancel. Same thing with the t squareds. So right away, you could have seen that the problem was just going to be 2 cubed over 2 squared. The next one, we're doing x to the negative 2 over x to the 4th. Negative 2 minus 4 is x to the negative 6. And then we have y to the imaginary 1 over y to the negative 1. So we're doing 1 minus negative 1. That becomes plus, so we get y squared. So we put this together, we have x to the negative 6, y squared. And now remember, if you have a negative exponent, you're going to write your answer as a fraction. The part with the negative exponent is going to move to the bottom. So here my x to the negative 6 is going to move to the bottom to become positive. And then the y squared is already positive, so it stays on top. So my answer is y squared over x to the 6. These last ones, we're going to review one of the other rules, which is power of a power. Here, when you have a power of a power, like an exponent next to another exponent, you're going to multiply them. So here we're doing 4 times 5, which is a to the 20th. In the next one, we also have a power of a power, but here we're going to have it give it out to everything. So it's like we're giving everything the power of 2. So I have x squared, and I'm giving it the 2. I have y, I'm giving it the 2. On the denominator, I have x, I'm giving it the 2. I have y cubed, and I'm giving it the 2. And then just remember, here we would multiply. So 2 times 2, that becomes x to the 4th. Here we just have an imaginary 1, so that would be y squared. Here I have an imaginary 1, so 1 times 2 squared. And here 3 times 2 is 6. Now we're not done with that problem yet. Now it's a division problem. So since it's a division problem, we can do the like terms. So I'm going to start with the x's. So x to the 4th over x squared. It's going to be x squared. And then y squared over y to the 6. Going to be y to the negative 4. Because remember, when you divide, you subtract exponents. So this simplifies, and it equals x squared y to the negative 4. And then here we have a negative exponent. Remember, you don't want negative exponents. So I'm going to write my answer as a fraction. And that y to the negative 4 is going to go to the bottom to become a positive 4. The x squared will stay on top. Our next problem, we have a negative exponent in general. So here, when we have a negative 1, that means we're going to take the inverse, or the reciprocal. And when you do that, it will become to a positive 1. So I'm just going to flip everything. And since I'm flipping everything, this exponent becomes now a positive 1. So we can really ignore it. It's like the 1 can be imaginary. So we have a to the negative 3b squared over a squared b. And now we can work it out like a division problem. Here I'm going to put an imaginary 1. So I have a to the negative 5th and b to the 1. And then remember, you don't want negative exponents. So at the end, I'm going to write my answer as a fraction. Since the a is negative, it goes to the denominator to become positive. And the b to the imaginary 1 would stay on the top. So again, anything with a negative exponent, we're going to move it to the denominator. These last problems are going to put everything together. So here, this is a multiplication problem. So right away I noticed that. So I'm going to start by multiplying my coefficients, or the big numbers in front. Here I have an imaginary -1. So I'm going to do 4 times -1 times 3. That comes out to -12. Now I'm going to do my j's. So I have j times j to the -2 times j cubed. Here I put an imaginary 1. And when you multiply, you add exponents. This is going to become j to the imaginary 1. Or actually, j squared. Because we get -1 plus 3, which is 2. Now we can do the k's. We have k squared times k to the -7. Remember, when you multiply, you add exponents. So we get k to the -5. So now if we put all this together, we have -12, j squared, k to the -5. And then remember, we don't want negative exponents. So I'm going to write my answer as a fraction. Now, it's okay to have a negative number. So the -12 is going to stay -12 there on top. The only thing you move to the bottom is something with a negative exponent. So -12 and j squared stay on top. We're going to move the k to the -5 to the bottom to make that 5 become positive. In our next problem, we're going to have to do it different because we have to do our exponents first. So we can't multiply everything till those squares disappear. So here, I'm going to leave the 1/2 separate. And in this parentheses, I'm going to have to give everything the squared. So I have -5 squared, a squared squared, and b cubed squared. Here these have imaginary 1s, and I'm going to give everything the squared. Now, -5 squared, we do like we normally do. So it's -5 times -5, which is 25. And then remember, when you have a power of a power, you're going to multiply these numbers. So all these numbers we're multiplying times each other. So I get a to the 4th, b to the 6th, a squared, b squared, c squared. Now, we're not done because there's several like terms here. We can combine the a's and the b's. Now, since they're multiplying, you add exponents. So I'm going to start with my big numbers. 1/2 times 25 is 12.5. And then for the a's, I'm going to add my exponents. So I have 4 and 2. 4 plus 2. For my b, I add exponents. So I have 6 plus 2. And then I have c squared. So this becomes a to the 6th, b to the 8th, c squared for our final answer. Now on the last problem, this is just going to combine everything together. I have a power on top, so up here I'm going to have to give that 2 to everything in that parentheses. So I'm going to give the 3 the 2, m squared the 2, and to the imaginary 1 the 2. And now I'm going to simplify. I'm going to focus on this section right now. I'm just going to focus on rewriting it. So I have 2mn squared. 3 squared is 9. And then I have m squared, n. You do 1 times 2, you get 2. Now on the numerator, I can multiply things out. So it's like a multiplication problem on top. So if I do 2 times 9, I get 18. Here I'm going to put an imaginary 1. When I combine my m's, since we're multiplying, we add exponents. So m to the 1 plus 2 is going to be m cubed. And then n to the 2 plus 2 is going to be n to the 4th. Now it's a division problem, so normally we would subtract exponents. But if you notice here, these are the same, m cubed and m cubed. So they cancel, n to the 4th, n to the 4th cancels. So we're left with 18 over 12. And we can just simplify that. If I divide those numbers by 6, it becomes 3/2 or 1.5. Either answer is correct. So there will be some times where you have to put everything together. Don't overthink it. Just remember, when you're multiplying, you add exponents. When you're dividing, you subtract. Anytime you have a power, you multiply those little exponents together. If there is no exponent, you can always put an imaginary 1. And you don't want negative exponents, so if your answer does have negative exponents, rewrite it as a fraction and move anything that has a negative exponent to the denominator. It's okay to have negative numbers. Those you leave alone. It's just not okay to have negative exponents.